All right, welcome to 6.3b. Now we're going to solve trig equations for all values of theta. And so what we're going to do is a basic trigonometric equation asks for what values of theta cause the trig function to have a specific value. And so that's what we were doing in the last one. And so he's reminding us that when we did something like cosine theta equals 1/2, we'd say, hey, where does cosine theta equal 1/2? And the reference angle would have been pi over 3. Pi over 3 has a cosine of 1/2. And so from 0 to 2 pi, that would have happened twice. It would have happened where the two times where cosine's positive, namely in the first and fourth quadrants. And so that's what we have, a first quadrant angle and a fourth quadrant angle as an answer. But if we don't limit that, then it can be basically a circle all the way around. So we're going to be adding or even subtracting 2 pi because they could be negative. So every time you add 2 pi, you come right back. So if I'm here at pi over 3 and I add 2 pi, I come right back to that. Add 4 pi, I come right back to that. 6 pi, right back to that. And so as long as you're away 2 pi radians, you could add 2 pi or 4 pi and you're getting right back there. So that's what he's pointing out here. And he's also pointing out that you can go backwards and get that, right? It wouldn't matter that I went forwards. I could have gone backwards 2 pi. So essentially what we come up with is this type of response. What we're going to do, it's very methodical and it's very easy. We're going to go find the 2 times, or maybe even 1 time it happens between 0 and 2 pi, and then add 2 pi times z. Now z stands for an integer. It can be any number, right? It represents all integers. So integers are things like ... -4, -3, -2, -1, 0, 1, 2, 3, and that pattern just continues. So any of those numbers. So as long as you have those numbers, if we have an even number of pi of them, you will be right back to where you started. So let's watch this in action. So here's example 1. So notice the directions and pay attention. They're separated on the exam as well, but pay attention to the directions in the exam. In this case, we want for all real numbers. So this is where we're going to want to have the 2 pi z. So this is going to relate back to example 1 in 6.3a. Sine theta equals 1/2. We know that. That's a pi over 6 reference angle where sine's positive, and that's in the first quadrant and in the second quadrant. So we get those 2 times that it happens from 0 to 2 pi, right? Then all we have to do to conclude is add 2 pi z to our answer, and that's it. So if we come down here to secant theta is equal to √2, secant theta is the flip of cosine. And so we know that secant theta, being √2, is going to be at a pi over 4 reference angle. Well, we need secant theta is related to cosine. Oh, students take calculus. So that's going to be a first and fourth quadrant angle. And that's what we get, a pi over 4 and 7 pi over 4 angle between 0 and 2 pi. Now to get every other one is on those 2 lines, and so they're all 2 pi away. So we find out that it's at pi over 4. We're basically doing the previous section stuff and just adding 2 pi times an integer. 2 pi times an integer, and pick your favorite integer and it will work. So what about when it's -1? We got to think about where cosine theta is -1. Well, cosine corresponds to x's. X's being -1 would be right out here, right? That's an x distance of 1 away in the negative direction. So that's why he's labeling pi. And that's the only time that happens from 0 to 2 pi. So how do we finish? What's this new section add? That we add 2 pi z to our answer. And so here's his note. Since there was only one solution for the equation on the interval 0 to 2 pi, there will only be one expression in terms of 2 theta to represent the numbered solutions. This will occur for all the following situations. It will occur for any time their sine or cosine is equal to plus or minus 1. So you can kind of park that in your memory as a pattern that's absolutely true. All the solutions to the basic trig answers have answers in terms of multiples of 2 theta. In most cases, this requires 2 separate parts to answer, but as we saw in the previous example, some just one. Some basic trigonometric equations have answers that can be expressed in multiples of 1 theta. Maybe he should have said 1 pi, but let's see. In these cases, the entire solution can be expressed as a single expression in terms of the multiples of 1 theta. I believe that those should be pi's, right? And multiples of 2 pi. Theta is some random thing, so there's some typo there. So let's see what he has here. Cosine theta equals 0. Well, look at where those are happening. Cosine corresponds to x, and x would be 0 here and here. So that's why we're getting pi over 2 and 3 pi over 2. And so one way to answer it is two separate answers, right? Same thing that we were teaching, the two solutions. But take a look that they're only 1 pi apart. See, he was supposed to put a pi down there. Those are related. Look at this. They're just 1 pi apart from one another. So we really could get by with the first one plus pi times z. Just adding pi every time. If you add pi times z, you're going to go from here to, you're going to go from that top one to the bottom one to the top one to the bottom one. And so a more succinct answer is right here. It's exactly the same as this, and we want you to go for the succinct answer. If you can write it as 1, take a look at why you couldn't do that before. So these were exactly opposite one another. From a very visual point of view, you can see that. Let's come back up here. Remember, our two equations, or two angles, were right here and right here. They're not right across from each other, so you're not going to be able to get through with just a pi. Same thing up here. If we go and look where these guys were, first and fourth quadrant, right? So again, not right across from each other. The only reason we were able to get by with 1 in this setting is because they were directly across from each other. Let's see another example. Tangent. Tangent theta is root 2 over 2. Well, we know that that is a pi over 4 reference angle, and because it's positive, it's in the first quadrant. And it's in the third quadrant, right? All students take. And this is going to be 5 pi over 4. Now look, they're right across from each other, directly across. So you're going to be able to get through it with just one single pi, because they're only pi radians apart. Same with cotangent. Cotangent theta being negative root 3 is going to be related to a pi over 6 reference angle. So notice that all of a sudden he's dropping all of the details about how to justify that that's pi over 6. That's the previous sections. That's what's got to be done really quickly, is say, okay, how can I justify what the reference angle is? So that homework you do in that second section, or 1b, I guess, is really, really important. So a pi over 6 reference angle, but cotangent, all students take calculus, it's going to be negative in the second and third quadrant. So that's where they're coming up with 5 pi over 6 and 11 pi over 6. But look, they're right across from each other, so therefore we can get by with just a single pi. And so 5 pi over 6 plus pi z will do it. You do not need the 2. In fact, you need both answers, but we want it as succinct as possible. So if you can get by with the single single angle plus pi z, and you give me 2 angles plus 2 pi z, it'll be marked wrong. I need you to get that succinct answer as modeled in the homework.